Welcome back to Geometry, Chapter 3, Section 2. We're going to talk about parallel lines and when they're cut by a transversal. So, these two lines, that one and that one, are parallel. How I know they're parallel is because they have those little matching black triangles on them, which is the symbol for lines being parallel. They have another line cutting across them, and that's called a transversal. Okay? Now, first of all, I've numbered the angles that are caused from the transversal cutting through the parallel lines. This is angle 1, 2, 3, 4, 5, 6, 7, 8. And I did it all on one diagram, where in your book they did 3 or 4 different diagrams, 4 different diagrams, and renumbered them for each one. So the numbers that I'm going to say are different than the book, so don't look at the book right now. Just pay attention to the concepts and you'll get it. It's easy. Alright, so here's our next postulate. Remember, we use postulates and theorems to prove things. And this is postulate 15. Corresponding angles postulate. So 1 and 5 are both, if this was a circle, they're both in the top right side. Do you see that? They're both in the same position, the top right side. And they are equal to each other. They're congruent. Their measures are equal. 1 and 5 are equal. 4 and 8 are equal. 3 and 7 are equal. And 2 and 6 are equal because they're in the same position. So if you have parallel lines cut by a transversal, angles in the same position are the same measure. Okay, here's our next one. Alternate interior angles are congruent. So angle 3 and angle 5 are on the inside of the railroad tracks on opposite sides of the transversal. So they are alternate, because they're on opposite sides, interior, inside the railroad tracks, angles, and they're the same. So 3 and 5 are the same, and 2 and 8 are the same. It looks like it, doesn't it? Okay, the next one is alternate exterior angles. So the ones on the outside that are on opposite sides of the transversal are the same. So 4 and 6 are the same, and 7 and 1 are the same. And if you look at it, they look like they'd be the same, don't they? Okay, the next one is, if you have two lines that are parallel, H and K are parallel, and one of them is at right angles to a transversal. That means this is 90 degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees. Then it is also, our transversal will also be perpendicular to the line that is parallel to it. H and K are parallel, so therefore J is perpendicular to H and K. And it makes sense, because they're in the same place, they're corresponding angles, so of course that's 90 degrees. Those are 90 degrees. Remember, we learned that postulate that if a line crosses another one perpendicular, it makes 4 90-degree angles. Not bad, right? Okay, so let's use this. Let's use what we can know. Here we have two parallel lines. See the black triangles cut by a transversal. That's our transversal this time. And we are told that angle 5 is 65. And we want to know what's angle 6. How we know this is vertical angles. Remember, angles across from each other, when we cross two sticks, are equal to each other. So that means if 5 is 65, 6 is 65 too. Okay? So measure of angle 5 and measure of angle 6 are 65. And how do we know that? Alternate interior angles. Okay? The next one is that the measure of angle 7 we can figure out. Because 5 and 7 are a linear pair, we can say 180 minus angle 5, which is 65, and 180 minus 65 is 115. So we know angle 7 is 115. And how do we know that? It's because we know that they're a linear pair. And we know that a linear pair, a straight line, is 180 degrees. So we can just say that this is the linear pair postulate. Okay? The next one we have is that we can know that 8 is in the same position as 5. Do you see that? That it's in that same position. So 8 is also 65 degrees. And the reason why we know that is our corresponding angles postulate. That angles in the same position have the same measurement. So we know 8 is also 65. Okay, and we can know that 9 is also 115 because 9 and 8 are a linear pair. Did they say linear pair postulate? No, they used a different one. There's more than one way to do this. And this is something you're going to find. There's more than one way to be right. There's a whole bunch of ways to be wrong in geometry. So another way we could do it is alternate exterior angles. They're outside the railroad tracks and opposite side. So we'll do the same as them. Alternate exterior angles. All right? So that wasn't too bad, and we would know that this one's also 65, and we know this one is also 115. We know this one's also 115 because of vertical angles. All right, here's another one. We know this is 120, this is angle 1, and we are going to figure out what angle 1 is. Okay, we can tell that 120 and this angle are the same, and so this is also 120. So 120 and angle 1 make a straight line 180 by the linear pair postulate. So we can, why is measure angle 1 not alone? It's being added to 120. So what's the opposite? Subtract from 120. What you do to one side, you do to the other. These cancel out. 180 minus 120 is 60. So this angle right here is 60. This one's also 60. That one's also 120. This one's also 120. This one's 60. And that one's 60. All because, and that's if these are parallel. Now, in reality, they said you could do this with a leaf. No one's really doing that. They try so hard. And they try so hard to make nice pictures in the math book, but it's one of those dumb, someone's buying 50 watermelon problems. All right, so we talked about that one. Here's another one. Here's two parallel lines cut by a transversal. This one's 125, so we know angle 4 is also 125 because they're in corresponding places. Does that make sense? And we know that angle 4 plus x plus 15 is 180 because these two things make a straight line. So we can substitute in for angle 4, 125. Now we solve for x. And what we have to do first is gather up our terms. We gather up this 125 plus 15. And we have a song to go with that. Gathering up your terms, stowing away the time. This one has a dance. It's 2 on each side. Okay. So now 125 plus 115 is 140. We bring down what we didn't mess with, so you bring down the x and the 180. And now we ask ourselves, so why is x not alone? Because it has a plus 140, so what's the opposite? Minus 140, what we do to one side, we do to the other. Those cancel out. 180 minus 140 is 40. Notice I didn't write the equals bar there. Those bars mean divide in algebra, so we just leave them off and write the answer down there. So x equals 40. This is a very typical problem we will do in geometry a lot, and it gives you an opportunity to practice that as algebra skills before you move on to the super hard algebra 2. So it's really important. Okay, the next thing was a word problem, and it talked about, this is historically true, that there was a guy back in ancient Greece who figured out how big the world was using alternate interior angles. So he found two towns, Syene and Alexandria. He picked a day, and he said that the light rays from the sun were parallel. He knew how far apart they were, 575 miles. And so then he put a stick in a hole so that it would make a shadow. And that was his idea of a transversal, which would go through the center of the earth. And he figured out that it was 1/50th of a circle and was able to figure out from that, because he knew how far apart the two towns were, that the Earth was 29,000 miles. And he would have been right, but they had mismeasured what was a known fact, that these two towns were 575 miles, was wrong. So he would have been able to get the right answer, which shows me that I really don't think people are evolving and getting smarter, because he figured this out over 2,000 years ago, and that was mighty smart, wasn't it? But anyway, so I thought that was all interesting. Be sure you read about it in your book, and I'll see you on the next video. Math is fun.